Hello class, welcome to your very first video lesson. Today we're going to be talking about basically half of the atom. We're going to be diving into the nucleus of the atom, which we'll do a drawing here in a second, and looking specifically at the protons and the neutrons. Now, these words should not be brand new to you. We've been doing these, we've been using these. We used them in the first unit when we talked about nuclear chemistry, and they've come up a couple times since then. But we're going to review protons and neutrons really quick, and then we're going to dive into isotopes. Now, the word nucleus. All a nucleus is the center of an atom. So if we do a drawing, there's a couple of different ways we draw atoms. There's what I call the Jimmy Neutron style, which is a dark center with some rings around it. If you grew up watching Jimmy Neutron, you've seen this display. There is a dark center with basically dotted hula hoops around the outside. But in both of these drawings, the nucleus is a small, dense center for an atom. So we're looking at that small, dense center. Inside that dense center are our protons and neutrons. And we've done these drawings before where we zoom in on the nucleus and draw our protons and neutrons. So we're going to loop back to our favorite element from Unit 1, radium. Now, radium on the periodic table gets its very own element card. It is element number 88. And it has a mass of approximately 226. Now, quick review with these element cards. The 88 at the top, this is what we call the atomic number. And your atomic number is always equal to your number of protons. Ra is our element symbol. Radium is our name. And then if you remember, this 226 is actually our element's atomic mass. And atomic mass is equal to our protons plus our neutrons. All things we've done before, and now we can take this and we can draw the nucleus of radium. Inside our nucleus, we get our two particles, our 88 protons. And then to figure out our neutrons, we have to do a little bit of math. I know my total mass is 226. I know my protons are 88 of that mass. So to figure out my total number of neutrons, I need my total number of particles minus my protons, and I have 138 neutrons. This is the nucleus of radon. That's all that these vocabulary terms are. Things that you guys have been doing, but now we're tying a little bit more vocabulary to them. A little bit more about these particles. So protons. If you guys remember, protons were abbreviated as P plus. That little plus sign means that protons are positive. All protons live in the nucleus. And then all protons have mass, which means they have weight. In the world of subatomic particles, these are pretty substantial particles. They have a mass, they have a positive charge, and they live in the nucleus. I'm going to make that a little bit more obvious as a plus sign. Neutrons are very similar. Now, neutrons, if you guys have been following that symbol, are n little zero. That zero means they are neutral or they have no charge. So basically, they have no attractive property. A neutron would be like putting a magnet next to a piece of plastic. There's no attractive property at all. They're just sitting next to each other. Protons have a positive charge. They have that attractive property to them. Neutrons, however, are similar in our other ways. They also live in the nucleus. And they also have mass. So in your homework sheets, that first sheet is given an element card, draw the nucleus, or given a nucleus, draw the element card. This is all that first sheet of homework is. Correlating an element card here to a nucleus here. Now, we'll go ahead and run through 2 more examples in this video so you have a better idea of what I am looking for. So, example 1, we are going to start with the element of bromine. We'll do bromine. Bromine is element 35. It is Br. And it has an atomic mass of 79.9. Now, a lot of the elements have a decimal atomic mass. What you're going to want to do for our purposes is round that. 79.9 is going to round up to 80. So this is our element card for bromine. We are tasked with drawing the nucleus. Inside my nucleus, I get 35 protons. And I know the total mass of my nucleus has to equal 80. So if I need a mass of 80 and 35 are protons, the remaining weight must be coming from the neutrons. So I have 45 neutrons. In my nucleus for bromine. All right, that's example 1. Example 2, let's apply the same logic and work it backwards. So in example 2, your card is going to be blank. And your nucleus is going to be filled. So I'm just going to pick a number, 31 proton. And let me see. Let's do, double check, make sure my math works out. Yes, 39 neutrons. Now, here you've got to remember way back to when we started our notes. Our protons are actually our launching point because our protons give us our atomic number, which is going to fill out our name and our symbol. So my protons in this example are 31 protons. So I'm going to pull out my periodic table. Sorry about the glare. I'm going to find element 31. Element 31 is gallium, Ga. And then to get my mass, I'm going to continue to work backwards. So my total mass before was my given. Now I've got to figure out my total. So 39 plus 31 is going to give me a total mass of 70. So my mass for gallium is 70. So here's a couple of practice problems, working forwards, working backwards, and really getting into our head that these protons and these neutrons are related to our element cards. If you know the protons, you know the element.